Welcome to the Professor's DuBois channel. This video is a mini lecture based on our second lecture covering material from Chapter 2. Disclaimer: this is in no way equivalent to our actual lecture where we discuss and practice the material in much more detail.
7 elements exist as two of the same element bonded together and are called diatomic elements. The subscript of 2 means there are 2 atoms. We will learn why later in this semester. For now, you should memorize these 7. Some periodic tables will show the state of the element, and it's interesting to note that only 2 elements exist as liquids and 1 is a metal. There are some elements that exist as gases, but most are solids.
See how the diatomics will form the number of 7 if we exclude hydrogen? This might be a helpful reminder, and there's also some popular mnemonics for this purpose also.
Allotropes exist when an element can arrange itself in multiple ways, resulting in different properties. Carbon is an excellent example. Graphite is the material in pencil that marks the paper. Graphite is made up of only carbon atoms. Diamond is also made up of only carbon atoms, but they have very different properties.
Covalent compounds are made up of nonmetals only. Remember, these are on the right-hand side of the periodic table, with the exception of hydrogen, which is also considered a nonmetal. The way nonmetals form compounds is usually in simple molecules with atoms in fixed ratios. But there are some covalent compounds that form three-dimensional network structures, and these are very strong.
We represent molecules using formulas. The subscripts tell us how many of each element there are in the formula. Empirical formulas are the simplest whole number ratio.
There are many methods of representing formulas. The molecular formula is very easy to type, but does not give us information about the arrangement of the atoms. The condensed structural formula can be used to describe the arrangement. The others will visually show how the atoms are arranged.
We will begin our naming of compounds with binary molecular compounds. This means that they will have 2 elements and both are nonmetals. There are specific rules for this type of compound.
When naming molecules, we will use prefixes to describe how many of each element are present, and you will have to memorize these.
When naming binary molecular compounds, start with the first element. If there is more than 1, use the appropriate prefix. If there's only 1, then you do not need to use the prefix. For the second element, you will use a prefix even if there is only 1. You will also change the end of the name to IDE or IDE. 3 examples are provided. Notice that the second and third example only have 1 of the first element, so no prefix is needed. The second element will have the prefix mono if there is only 1. An example is carbon monoxide. Try to write the formula for carbon monoxide and use Google to see if you're correct.
Many compounds have historical names, and some examples are shown. It's still okay to use the naming system that we described. We would like you to memorize ammonia and water because we will use these molecular compounds often throughout the semester. Water can also be called dihydrogen monoxide by our naming convention. You can find a pretty funny petition to ban dihydrogen monoxide using Google.
Inorganic acids usually start with hydrogen, and these are soluble in water and produce the hydrogen ion. We name these in a similar fashion, but leave out the prefixes. You can name inorganic acids using prefixes, without prefixes, or by the common name for credit in our exams. Oxoacids are an acid that contains oxygen. Prefixes and suffixes are used to describe the number of oxygen atoms present. You will not be responsible for naming oxoacids on the exams.
Alkanes are a group of organic compounds that consist of only carbon and hydrogen, and they follow a specific pattern. The ratio of hydrogen to carbon is 2 times the number of carbon atoms plus 2. Since ethane has 2 carbons, we would say 2 times 2 plus 2 for a total of 6 hydrogen atoms. These all end with the suffix ane, and indicate that all the bonds are single bonds. The prefix tells us how many carbon atoms are present. Notice, these are not the same prefixes we used when naming binary covalent compounds. Who said chemistry was easy, right?
We end the lecture with some naming practice. Take the time needed to learn how to name binary covalent compounds because we will introduce a different type of compound with a different set of naming rules in our next lecture.
Thanks for watching. Please give the video a thumbs up and subscribe if you would like to see more mini lectures on the Professor's DuBois channel.